we are going to learn about one more form. We have looked at standard form, we have looked at vertex form, and now the third kind of form is called root form. I have in the past, instead of calling it root form, many books call it factored form. Have we heard of factors before? Have we factored and factored and factored for weeks and weeks and weeks? Okay, so why do you think this might be called the root form? What do you think you might be able to find with a root form? What are roots? The roots are the x-intercepts. The x-intercepts are on the x-axis. And what is another name for roots? Okay, zeros, what else? Heard somebody? And x-intercepts. And I'm going to show you in a minute why they're called zeros, why you could call them solutions. I'm not really sure where the term roots comes from. Maybe if you had a little bit of an imagination and you had a parabola looking like that, and maybe that kind of looks like roots underneath the ground. I don't know. But these points right here are the roots. How many roots are there usually? 2. And what kind of form is this in? This is standard form. So how do I get it from standard form to root form? Another name for root form is factor form. And so do you remember how to factor? Do you remember that you multiply the first number times the last number and you get the number 18? And you write down the factors of 18. And you look for the factors of 18 that are going to add up to get a 9. Can you find any factors? These factors right here would add up to give you 9. Since this is equal to 1, since the A is equal to 1, I can use the shortcut factoring. You can use the long factoring. You will get exactly the same answer. That is in factored form. That is the same thing as root form. Root form and factored form are the same thing. So, what are the roots? Well, you find the roots by putting this equal to 0. Hence the name zeros, because you find them by making them equal to 0, and then you solve them. Hence the name solve. And so these are called solutions because you solve to get the roots. Now, you don't have any graph paper in your notes, but I did make a graph of this equation. And so when you make a graph of these equations, these are the x-intercepts. Do you see that that goes with the roots you just did? Okay, so right here I need to fix the number because I wrote down the wrong number. So these are your roots. Do you see how that goes with the graph? Can we tell what the y-intercept is from this graph? I did want to mention that this number right here, if you were in standard form, this number right here would be the y-intercept. And that's why I don't see it on this graph, is because I don't have a big enough graph paper to see a y-intercept of 18. If you're in standard form, this number right here is the y-intercept. Did I say this number was the vertex? This number is not the vertex, unless you have a special kind of problem. We'll get to that in a minute. Okay, so problem number 2. To find the roots, we need to factor. What are we going to do first? Do you see a GCF? What's a GCF? So I'm going to factor out a 2. Then I am going to multiply the first number times the last number, and I am going to write down the factors of 32. Is there a pair of numbers that can add up to get me a -4? Since this is 1, I can use the shortcut factoring. I have the 2 out in front. That is the root form. The factored form is the root form. All of that factoring you were doing a couple of weeks ago, what you were finding can also be called the root form. And then you solve it. Now the 2 can't be equal to 0, but you solve this equal to 0, or this factor equal to 0. Let's see if I can write down the correct number this time. And so those are your 2 roots. All of that solving that you were doing a couple of weeks ago, what you were finding was the x-intercepts. That can also be called the roots. Now, what would the y-intercept on this graph be? This number right here is going to be the y-intercept. Am I going to need a pretty big graph to be able to see that number on a graph paper? So you can see on this graph paper, I had to go way down here past -7 to be able 70 to be able to figure this on the graph. But do you see those 2 numbers are the roots that we just came up with by factoring? Now, in example number 3, it's already factored for you. By the way, if I wanted to, I'll get to that in a minute. I'm a step ahead of myself. So, how do I find the x-intercepts? If you solve those 2 equations, what are the x-intercepts? So 3 and 5. And so the roots are 3 and 3, and the solutions, the correct form for the solutions are x equal, because when we solve something, we are usually solving for x. Now, how are we going to change this thing into standard form? Over here on the board, standard form does not have any parentheses in it. So how am I going to get rid of the parentheses that are in this? A box problem. Now, this is 2x minus 3x minus 5. Did I copy that down correctly? You can distribute the 2 first, or you can do a box problem first and then distribute the 2. I'm going to go ahead and distribute the 2 first. And then I'm going to do a box problem 2x squared minus 6x minus 10x plus 30. And then you combine like terms. And so when you combine like terms, you will get 2x squared minus 16x plus 30. To put a factored problem into standard form, you use a box problem or FOIL to multiply it out. Now, what's the y-intercept going to be? This number right here in standard form gives us the y-intercept. Now, how do we get the vertex? Well, there's two ways. Since we have it in standard form now, you could use this formula that's over there on the board with the standard form. But I think there's an easier way by just using some common sense. Do you have any common sense? If those are the roots, where is the axis of symmetry going to be? Would you agree it's going to be halfway in between that? Would you agree that the axis of symmetry would have to be right there? And what is going to be on the axis of symmetry? Is the vertex point going to be on the axis of symmetry? And so the first part of the vertex is going to be a 4. Because it's got to be on the axis of symmetry, and the axis of symmetry has to be halfway in between the roots. That's the same number you would get if you put it into the minus b over 2a formula. Okay? Just like when you use the minus b over 2a, you got the first part of the vertex. How do you get the second part of the vertex? When you have the minus b over 2a number, how do you get the second part of the vertex? Plug it in. Now, you can plug it into this or that. You will get the same answer. Most of the time, what I've seen today is people using that have been making sign mistakes. So let's plug in that 4 into this equation up here in place of the x. 4 minus 3, 4 minus 5. Put that in your calculator just like that. Put that much into your calculator, and what is that going to be equal to? What? And so that is going to be my vertex. 4 and negative 2, and so the parabola is going to go like that. How do I know the parabola is going to be pointing up? What's the A? This is the A. The A is positive, so it's going to be pointing up. Okay. So, this is already in root form. It's already factored. So, to find the x-intercepts, you solve those two little equations. If you solve those two little equations, this is going to be the roots and the zeros. X equals negative 2 is the solution. X equals positive 2 is the solution. Now, how do I get from root form into standard form? Well, it's got parentheses. To get rid of the parentheses, I'm going to use a box problem or FOIL. What's going to happen to those terms? They're going to cancel out, and so this is going to be x squared minus 4. So what's the y-intercept going to be? And so halfway in between negative 2 and positive 2, what's halfway in between negative 2 and positive 2? 0. And so my vertex is going to be 0 something. So I'm going to plug in a 0. I'm going to plug in a 0 in place of the x. And, oh, I made a sign mistake when I copied that one down. So what is this going to be when I multiply that out? Now, do you notice that the y-intercept and the vertex are the same thing? After I did this example, the students were putting the y-intercept and the vertex as the same thing on all of the problems. On this problem, are the y-intercept and the vertex the same? On any of the rest of the problems, are the y-intercept and the vertex the same? Why are they the same in this problem then? Because the axis of symmetry is 0. That's why these are the same, because the axis of symmetry is 0. These two are the same because in the standard form, the b is equal to 0. Do not take that to mean that these are the same in all of the problems, because they are not necessarily the same. Only if the b is equal to 0 will those be.